Okay, so today we're going to continue with two more circle theorems, our properties. So the first one, which I call as the bow tie or the butterfly property. So what it says is that angles at the circumference of a circle subtended by the same arc are equal. So what that means is, in the diagram on the left, let's consider the arc AB, so the curvy bit AB. Now we look at the angle created by joining A to D to B, and then we have another angle that goes from A to C to B. So angle D and angle C are both subtended by the arc AB because they both end on the points AB. So when that happens, the D angle and the C angle are exactly the same angle. So when you're doing these questions, you're trying to look for that butterfly or the bow tie shape inside your circle. It's a bow tie shape because you end up the angles having connected or sharing the points A, B at the bottom there. So the symbol for this is, it looks like a bow tie or a butterfly. The next theorem we're going to look at is circle theorem number 4, which is talking about cyclic quadrilaterals. So a cyclic quadrilateral is a quadrilateral, so a shape with 4 sides, like that, but the vertices, the points of the quadrilateral, lie on a circle, lie on the circumference of the circle. So a cyclic quadrilateral is a quadrilateral 4-sided shape with the points, the vertices, lying on the circumference of the circle. What's so special about a cyclic quadrilateral? Well, it just says that opposite angles add to 180 degrees. So this angle B and the angle D, if you add them together, you should get 180 degrees. Similarly, if you get angle C and angle A, they're opposite each other, and if you add them, they should add up to 180 degrees. And the symbol for this circle property or theorem is just draw a circle with a quadrilateral inside it. So let's apply these two circle theorems in example 1. If you're looking for these notes from the textbook, they're on page 140 if you want to photocopy and cut and paste it into your rules book. So example 1 says we have some circles or shapes here. Let's work out the missing angles. So on part A, we can see it looks like the butterfly or the bow tie shape. So we can apply the first theorem we talked about today, namely that the pointy parts of your bow tie should have the same angle. So we know that A degrees is 30 degrees. Why? Because of the bow tie property. So you can draw a symbol to explain why your angle is 30 degrees. In the next one, part B, you can observe that, hey, we have a 4-sided shape, a quadrilateral inside a circle, and that the vertices of the quadrilateral are touching the edge of the circle, so that we have a cyclic quadrilateral. What cyclic quadrilateral means is opposite angles add up to 180. So in this case, A degrees and 128 degrees add to 180. So we can write that down. So A degrees plus 128 degrees is 180 degrees. Why? Because, explain using symbols, we've got the cyclic quadrilateral theorem. And so that means A degrees must be 180 minus 128. So A degrees must be 52. And similarly, we need to work out what B is as well. So opposite angles add up to 180. So we can write B plus 125 degrees is 180 degrees. Why? Because cyclic quadrilateral theorem. So B is 180, take away 25 degrees. So B degrees must be 55 degrees. And that's it for applications of these two circle theorems. So to-do list, give it a try, have fun.